main catch of this problem is that it's an ultimatum. It's saying all embedded systems have to have a microcontroller. As we discussed in one of the first lectures, there's a few different types of logic for how the control system is implemented. So things like PLCs, FPGAs, those are also existing for embedded systems. So question one, the correct answer was intended to be false. It's not the only type of control method. So that was where that one was wrong. Question number two is also false. I know we didn't really touch on it that much, but we did bring it up on the data sheet, and I did mention the microcontroller name quite a few times. Specifically for the Arduino Uno, it's using the Atmega 328P. The Atmega 2560 is the one that's used for the Arduino Mega, so that was the main thing there. So those two questions are fairly straightforward. Question number three is talking about the difference between the Princeton memory model and the Harvard memory model. That one is true. This one is referring to how program memory and data memory in Princeton, those two are shared. In Harvard, those two are separated. For question number four, this is just asking about the general definition for registers. This one is true. For question number five, this was asking about the various characteristics to consider. Question five is also true. Question number six about flash program memory. This one is just following straight from the broad definition. Flash program memory is non-volatile. It is not going to be lost. It's not temporary. So number six was false. For question number seven, this is talking about the different ports. This one is correct. We do have port B, port C, and port D specifically. So question 7 was true. Question number 8 was asking about the pin mode function. It can only handle one at a time, so number 8 was also true. Question number 9 is just kind of based off what we worked on for the timers in particular. There are only 3, not 5, so 9 was false. Question number 10 is talking about how timers operate as a system. So they are independent. They do send signals to each other. So question number 10 was true. Question number 11 was asking about the system clock. This one we didn't really touch on as much, but ideally you might have been able to piece some things together if you had looked at the timer table. So when we're talking about the clock select bits, you'll see that there are some options for external clocks. So that is the justification there for question number 11 being false. So for number 11, it's not that they cannot use it, you have to configure it to select it. It is an available option. So that would have been false for that question. For question number 12, the TCNT2 register, this is just trying to check if you recognize the different register names. The TCNT stands for timer counter. This is where it's storing the current value it's counting by. It is not related to configuration. So number 12 was also false. The correct register name that we would have expected there would have been the control and configuration register TCCR. For question number 13, the interrupts are, this one is where I think there might have been some confusion for how some of the short answer questions were responded to. It is technically a first come, first served in terms of as the interrupts are happening, the most recent one is handled. The key detail is more about the priority. If multiple happen at the same time, only one will really be handled. It's not which one was the fastest or the first. So question 13 was really hinging on having that priority portion as well. So question 13 was false. For question number 14, This is related to the interrupt vector table. So I believe I provided the interrupt vector list here, and you can see which one is highest or lowest. So timer 2 is below the pin change, so that technically has the lower priority there. So for that question that it was asking, timer 2 is going to happen after pin change, so 14 was true. And then for question 15, asking about the second interrupt not occurring while the first one is being handled, that one is true as well. So that was everything for your true-false questions. For the multiple choice, a lot of these are fairly straightforward, and we'll kind of go through some of the calculations for a couple of the other ones. For question number 16, I don't think anyone really missed this one. The item that's out of place is the LCD screen. The microcontroller is usually referring to the small compact chip that has all the main pieces of SRAM, timers, flash program memory, etc., but it does not include most of the peripherals, so the actual headers, any other external devices and things like that. For question number 17, this one is also fairly straightforward. So for that one in particular, the other options are all not correct. The first one is digital read can work on any pin, analog or digital. So B was not the valid answer. It's not more accurate than analog read, and it's not only usable in the loop function, it can be used elsewhere. So the correct answer there is just A. For question number 18, I think everyone is also fairly straightforward with this. Java, Python, and C++ are all considered high-level languages. Machine code is the only low-level language, so the answer there was D. For question number 19, we touched on this briefly in the lecture portion. The main thing was mentioning the size of the analog to digital converter, specifically being 10 bits, or 2 to the power of 10. That's how we get the 1023 as that maximum. So question 19 was C. For question number 20, everyone, I think, more or less got this appropriately. This is asking about configuring a general purpose input-output pin. So in particular, when we're asking about setting it up as an output, this is talking about the data direction. So that only applies to answer A, so question 20 was supposed to be A. The pin and the port register are involved with the GPIO, but it's not, it does not affect if the pin acts as an output or not. You could try to argue the port register is involved with controlling the output value, but the